All right, gang, part two of the handout. So you are the manager of a fast food restaurant. The business problem is to determine whether the population mean. All right, so I know. I have this. Has changed in the past month from its previous value of 45 minutes. So change doesn't imply to me higher or lower. So that tells me that the null and alternative hypotheses will be set up like this. From past experiences, you can assume the population's standard deviation is 1.2. So this tells me I'm going to use the z-test. Select a sample of 25 orders. Go ahead and look at the significance level. And from our sample, we can see the sample mean wait time was 5.1. Is there significant evidence at the 0.05 level to indicate a change in the mean waiting time to place an order in the past month? Okay, so what we got here is just like before. We got our first part setting up the null and alternative hypothesis, and then we've got the second part setting the standard of our test at 0.05, sample size 25. So guys, we're going to use the z-test, so I'm going to go to stat. And z-stat, one sample with summary. And guys, what am I looking for here? The third part, I'm looking for z-stat. And I'm looking for my p-value. So guys, our sample mean is 5.1. The standard deviation is 1.2. My sample size is 25. I have a mean equal to 4.5, not equal to 4.5. Guys, I've taught this class, well, I've taught statistics both at the graduate and undergraduate level at Shawnee State now for about 23 years. So I think I've taught statistics right at 150 times. It means I'm old. But I was going to tell you guys something. I see a lot of students who just jump into the problem. And I think it's a really bad idea to not set up the null and alternative hypothesis before you begin the problem, because you get down to this point and you don't have it set right there. Then you go into the problem, you just start pulling out numbers where if when you're reading this problem, this information is clear. When you're reading the problem as a whole. So I think it's critically important for you to set that up before you actually get to the stage where you enter it into StatCrunch. So I'm going to set the values. So the z-stat is 2.5. I usually round those to two places, and the p-value is 0.012. Do I need to multiply this by 2 because I have a not equal to? No. If you don't understand that, rewatch the ending part of the previous video. So guys, our p-value is less than alpha, 0.05, so our decision is reject H sub O. Now, will our confidence interval contain 4.5? Well, no, it won't, because we rejected that value. Okay? All right, now, I want you to compare the next problem. You're going to say, well, that's exactly the same. Now, I've changed it just a little bit. And I changed it a little bit because I want to show you how that you can really just change one word and really change the complete dynamics of the problem. So this time we have just a generic change, but when I go to problem number 6, you'll see that everything else is the same, except we want to see if the waiting time to place an order is actually increased. So guys, that changes again the dynamics of the problem, and it's going to change our p-value. Now our test statistic will be the same. So we're going to have h sub o mu, h sub a mu, but we want to see if there's evidence that it is increased from the 4.5. Now this is going to be the opposite. I'm okay on the test. Well, your test will be on or on my math lab, so it's going to require you to put in not equal to, but technically equal to there works for me. So guys, all the other information, I'm going to go ahead and just do z-stat. Again, we have the population mean waiting time is normally distributed, and we have the population standard deviation of 1.2, so it tells me I'm going to use a z-stat, one sample with summary. So gang, the sample mean is 5.1, the population standard deviation is 1.2, the sample size is 25. Now again, that can't be equal to, so I have to put in 4.5, so that equal to essentially represents less than or equal to. And but the important thing is I set the alternative correctly. That's critical. This equal to, less than or equal to is completely irrelevant in crunching the numbers for this problem. This part is critical. Set this wrong, you get the problem wrong. Now notice, as I said, our z-statistic, and let me go ahead and complete this out. Our alpha value didn't change, and our sample size was still 25. So I'm still, since the population standard deviation was known, I'm using and reporting the z-stat, which is still 2.50, but the p-value is 0.0062 from StatCrunch over here. Well, guys, clearly we have a p-value less than 0.05. So that leads us to reject h sub o. Now, I don't know about you, but if I really cared about this, I would, I mean, I guess I care because it's a demonstration problem, but if I was working for this fast food restaurant and I really cared, just saying that something had increased to me tells part of the story, but I would really want to know, well, what's it increased to? So, guys, I would want to come in and do a z-stat one sample with summary. Sample mean of 5.1, 1.2, sample size 25, and I'd want to come in and do a confidence interval of 0.95. So 4.63. To 5.57. So the mean wait time looks like it's increased somewhere between 4.63 and 5.57. All right, number 7. You're the manager of a fast food restaurant. Wow, what's going on here? Same stuff, right? But instead of increase, we have changed. But the difference in this problem is population standard deviation is unknown. Now, guys, the point I'm trying to make here is I made these 3 problems look very similar for a reason, because the fine print defines the problem. And if you're one of these sloppy readers who gets, completely distracted or just won't slow down long enough to read something correctly, you're going to miss a lot of problems just because what's going to get lost in the details. So, has changed tells me that I have a two-tailed test. Mean tells me mu and mu. Status quo tells me 4.5. Population standard deviation unknown tells me a t-test. All right, so alpha 0.05 and is 25. So guys, when I go to get my t-stat and my p-value, the test has changed, so I have to go to a different line. But luckily for us, we should have this all memorized. Well, ladies and gentlemen, we can't even do this problem because the sample standard deviation isn't given. So footnote, add info that the sample standard deviation is 2.2. All right, so equal to 4.5, not equal to 4.5, compute. So my z-stat is 1.364, and my p-value is 0.185. So guys, the p-value is higher than 0.05, so we fail to reject. H sub O. Now, it's kind of crazy, isn't it? We've done 3 problems here that kind of remind you a lot of each other, but 2 of them we got a reject, and then this one we got a fail to reject, and primarily it's because of some stuff behind the scene on this higher sample standard deviation. All right, guys, let's go on. The worldwide market share for Mozilla Firefox has been reported at 17%. So, guys, right there, when your population is defined by a percentage, you have a proportion problem, and no questions. Ask, you have a z-test for proportions. So H sub O is going to be P. H sub 1 is going to be P. Did I put H sub A previously? I sure did. I just realized that. So I guess that proves what I said in the very first video. H sub O and H sub, or I'm sorry, H sub A and H sub 1 are interchangeable. Guys, I've been doing this a long time, and I never use H sub 1, so you're going to see me slip up and use H sub A there. This is the evidence support the proportion is higher than the World Wide Web, so we want to know if this is higher than 0.17, which says that this, according to the book, would be less than or equal to 0.17. All right. 2, our alpha level is 0.05, and our sample size is 100. So we're going to have a z-stat as our test statistic, and we'll go get our p-value. So guys, over here, stat, proportion stat, 1 sample. I had a student one time say, well, what if I don't go there? What if I do? Well, you're going to get it wrong. Didn't work that way. All right, so number of successes. So there were 22 out of the 100 observations. And here we want 0.17. Again, that's kind of annoying because we can't put less than or equal to. But guys, it doesn't matter as long as you get that one set correctly. 1.331 and our p-value is 0.0916. So guys, our p-value is higher than our alpha. So we failed to reject H sub O, so there is not sufficient evidence to indicate that the percentage of students at Shawnee State University who uses Mozilla Firefox is higher than the worldwide market share. All right, at a 0.05 level of significance, use the sample data provided below to test the claim that the mean amount spent for lunch at a fast food restaurant is different than $6.50. Well, guys, first of all, the mean tells me that I have mu, and different tells me I have not equal to and equal to. So we want to know 650 and 650. Now, my alpha level is not given. Yeah, it is given, 0.05. And my n was that 2, 4, 6, 8, 10, 11, 12, 13, 14, 15. Is 15. Now, guys, it turns out that okay, one thing I could do if I needed to is I could just type these numbers, 7.42, 6.29, but it turns out that this is actually a data set that's from your textbook, problem 9.28. So I'm going to what am I going to do? I'm going to go back to StatCrunch and go to data set from your textbook. It comes from chapter 9, and it's called fast food. And I don't know about you, but that just beats the heck out of typing in those 15 numbers. So guys, population standard deviation isn't known, so I'm going to use a t-test. So that tells me I'm going to do a t-stat for the test statistic. And as always, we're also going to get a p-value. So I'm going to go to stat. I'm going to go to t-stat, one sample. But this time, guys, I have my data. I don't have my summary. So choose cost. I want mu to be 650. Mu not equal to 650. And essentially I'm ready to go. So my t statistic is 1.634. My p-value is 0.1245. My p-value is higher than my alpha. So my decision is failed to reject H sub O. So a summary of this in kind of the context of a business, we would say that at the 0.05 level of significance, there is insufficient evidence to reject the claim that the amount spent for lunch is different than $6.50. All right. Next question I just threw in. In the previous problem, there was no indication that the population was normally distributed. And when there's no indication that the population is normally distributed for a mu problem, now recall, for a p problem, we need n times p and n times 1 minus p to both be greater than or equal to 5. This is a different type of problem. This is an average problem. For this problem, we need a normal distribution, or we need our sample size to be 25 or larger. So Should we be concerned? Well, I don't know. What I would do is I would come over and look at a histogram. So I would go to graph, and I would go to histogram and look at the variable, and I would create one. And do I see, and again, I'm not looking for a normal distribution, because these 15 numbers aren't a population. These 15 numbers are a sample. So does that reasonably seem like it could have come from a normal distribution? I think so. It's fairly symmetric. I don't see any outliers. I don't see any extreme skewness. I'm going to look at something else. I'm going to look at a box plot. And the box plot, if I look at this line, look above and below, we got close to symmetric. It's not perfectly symmetric, but I don't see anything that just jumps off the page and gives me any concern that this data set didn't come from a population that was normally distributed. Can't prove it did, but it looks like to me, based on reasonable assumptions, that it probably did. Now, there's something called a, well, where is it? QQ plot, right? Let's take a look at a QQ plot. Now, a QQ plot, normal quantile plot, what we want to see here is we want to see our points make a straight line. Now, if these points all these points fell right on that red line there, then we would have something that definitely comes from a normal distribution. The more deviation we have from these points from that straight line, the more deviation we have from being assured this came from a normal distribution. So since these are quantiles, what it does, it comes in and gives measurements for the quantiles for the cost. And so I don't see any, this concerns me a little bit. This is row 6, cost 951, normal quantile 1.15. I don't know. Still, I don't see enough deviation from that vertical line, that y-x line, the diagonal line, because I've been putting up so many videos today, I'm about half brain dead, so you have to overlook me a little bit. So let me back up and slow down. If we have this diagonal line and all these points fall on the diagonal line, then we are assured normality, that the normality assumption is met. Unless these points vary a lot from the diagonal line, not the vertical line, the diagonal line, we still don't have to worry about the normality assumption. So when I look at this, I feel okay. I think conducting this study over here on only 15 subjects is something that I would feel comfortable conducting. All right, guys, one more thing. I want to just give you a problem and calculate a p-value. So let's say that we're testing sigma not known, and our sample size is equal to 50. So since the population standard deviation is unknown, we're going to have a test statistic that is t-stat. Okay? Now let's say that our test statistic is 1.05. I want you to calculate the p-value. Well, what I'm going to do is I'm going to think, well, And we're using a t-distribution again because this population standard deviation isn't known. I'm going to come to 1.05 and find the area to the right, because I have to come to negative 1.05 and find the area to the left, again because it's a two-tailed test. If I find this area right here, not to be confused with the rejection region, this is a p-value. Rejection region looks at the area to the right and left of the critical values. This is the test statistic, which is something different. So if I'm going to do that, I'm going to use the calculator. And again, since the population standard deviation isn't known, I have to use the t-calculator, t-distribution. Sample size is, 50? So I would have a degrees of freedom 49. And I can do either one. I can do above 1.05 or below negative 1.05. I'm just going to do above 1.05. And then I have to multiply that by 2. Another way of doing that is to look at between negative 1.05 and positive 1.05. Now guys, that's going to give the area in the middle. That's not what we need, is it? We need this area in the tails. So we'd have to take 1 minus that answer. So 1 minus 0.7011 to get the areas in the tail. So you can do it one of two ways. You can either find that area, multiply it by 2, or you can find the area in the middle and subtract it from 1. My advice to you is find one that you're comfortable with, stick with it. Don't deviate it, because sometimes when you deviate stuff, it doesn't work out well. All right, guys, have a good one.